So let's differentiate that function I showed at the beginning. 3x to the 7 plus 1. Oh, that was different. Oh, whatever. Plus x. Let's do x. Yeah? It was 15. Let's do this one. So it was cube at the beginning, but cube, at least you can kind of figure out times 1 times 1 times 1 times 1. Do you really want to do this thing 15 times in a row? No. So this is how you do it. I will show you the slow way and then the fast way. And then I do recommend you to do the fast way all the time. Don't do the slow way. But in the video, you'll see how they're saying this in a slow way. Identify who is outside and who is inside. That's your definite first step. Like in Matryoshka, you need to see who's inside and who is outside. What is the last? This is how you do it. Plug inside anything you want and see what's the last step you will have to do to calculate the result. For example, I'm plugging 1. The first thing I will do is 1 to the 7, then times 3, then plus 1. What's the last thing I will have to do? Raise to the 15, right? So then it means this 15 thing is the last function. That's like the outer layer, right? The outside piece. So the thing inside here is inner layer. That's what we're gonna call. I like calling it U, but let's call it a G to be consistent for this case. G. That's inner. Inner. Make sense? And now this is how you see it. So the formula says don't touch the inner layer because you cannot yet. It's inside. So you cannot approach it yet. Your job is to differentiate the outside layer. The outside layer is this something to the 15. And this is how I teach it. You should see it as something raised to the 15. How to differentiate something to the 15? 15 goes down. Something to the 14. All agree? And now the most common mistake students do is differentiating the inside part. No, the formula says you cannot touch it yet. You see this piece? It says copy. It means don't touch it. And that's why I'm saying something. So 15 goes down. And then something to the 14. What is this something? The green part, which we called inner function. 3x to the 7 plus x. So copy. That's what I will be repeating many times. Differentiate the outside, copy the inside, because you cannot touch it here. Now at this moment, differentiation of the outside Russian doll is over. You opened it. Now you take the inside piece. What's the inside piece? We just agreed. 3x to the 7 plus x, right? Now you can differentiate the inside piece. The rule says multiply. So you do times the derivative of the function inside, which is, what is that? 21x to the 6 plus 1. Good job. So this is inner. Inner prime. Copy inner. This is the fast way to do it. So this is how I would recommend to do it all the time. See what's inside, differentiate the outside piece, copy the inside, times derivative of the function inside. The long way, people actually writing this down. They say, okay, so this is G, let me do like some purple. G of x is 3x to the 7 plus x. G prime of x is 21x to the 6 plus 1. That's the derivative of the inner function. Derivative of the inner function. Then they're saying, well, actually, g of x is raised to the 15. So when I want to differentiate that, it will be 15 g of x to the 14. That's derivative of the outside function. And then you combine, you say that f, capital F of x, capital F of x, which was a composition of two functions. The outside was, let's call it f. So this is my f. Outside was f. Little circle means now inside is g. When I want to differentiate this composition, it will be a derivative of the function inside with the copy piece, g inside, times the derivative of g. And the result will be the same what we just had. F prime is 15, copy G. Here it is. Copy G. 3x to the 7 plus x to the 14 times G prime. G prime is 21x to the 6 plus 1. The answer is the same, but this one has kind of logic here. Inner function, differentiate inner function. Outer function, understand what kind of nesting we're working with. Not nasty, nesting, just to repeat. And then you finish differentiation. This is a long way. I saw some students doing it at the beginning, because some of you like to be very careful and structured. This is inner, this is outer. You will see. At some point it's just annoying to do it again and again. I will teach you how to do it fast. How to do it fast. You'll be proud that you can do it fast. At some kind of presentation, colloquium, group work, people show you the result and you're like, oh yeah, it's true. This is what derivative of that function is in your head. So you can do it in your head. I like that. And to be good at the exam, I like that. Ask me, what do you think? So this is a long way. Long way. Long way is to explain everything to yourself, basically. And then the first way is the fast way. This is how I will be doing it from now on. Derivative of the function outside times derivative of the function inside. Done. Yeah? Questions? What do you guys think? Chain rule is a challenging topic. I will show you many examples, and there will be many times you'll be like, what? It will be, you'll see, I will combine chain rule with product rule and quotient rule. It will get there. Okay, let's do cosine and sine. How about cosine? Your homework right now is about cosines and sine. You can do it. It's not too bad. It's like cosine times tangent, secant over sine, differentiate. So we need you to review trigonometric functions, because many of you are engineers. That's like we push it only for this class, 265. For the pure math class, we don't push it so hard. 3x cubed. Find derivative of this. Okay, the question still remains. Who is inside and who is outside? Look at it a little bit, think about that, and then tell me, what's the outside function? It's the one we have to start with. Cosine is outside. First of all, it's literally outside, because 3x cubed is the angle, right? So it's input for cosine. So in this case, it's actually more obvious. Second of all, you can check, plug x equals, I know, pi. You first cube it, then times 3, and then the last thing you will do is cosine of the result. So since the last thing you do is cosine, this is the outside layer, we're going to start with this. Okay, so I'm going to do this. This is inside piece, g of x, inner. That means I don't touch it yet. That's why I'm doing it, why I'm signing it. I don't touch 3x cubed. You have to keep it like this for now. You differentiate cosine. What's the derivative of the cos? Minus sine x, good job. Now what's important? Copy. Yes, good job. You guys are already getting it, I can see. Copy. Let me do different color. 3x cubed. Do not touch it. So, yeah, I want to write down. Do not touch it yet. Like, remember this. Do not touch it yet. Now you're done with the outside piece. Outside piece is over. So you do times, and this is actually the moment when chain rule happens. Chain rule. Chain rule is basically this product of the process going outside into the diving into the inside. Now you look inside. You can look either over here because we copied it, or you can look over here. Doesn't matter. It's the same. And differentiate that. You don't differentiate sine anymore, right? That's like done. Forget about it. Yeah, you just look inside. 3x cubed gives you 9x squared. Good job. And it's done. That makes sense? Can you do that? Not too bad. So inside prime. Derivative of the function outside, copy the function inside, times differentiate the function inside. Not too bad? Not too bad. Now, let's do this one and see if you like it or not. Again, keep in mind, so I just was reading about the motivation, how to study for classes, the one you don't like, and so on. And, I mean, you should like this class, but still, let's be realistic. It's not always fun. So the good motivation helps you to be faster with homework and stuff. keep in mind, this is kind of technical, it looks boring, but keep in mind that people are really using it for coding, medicine, for fighting diseases spreading around. They literally use chain rule, how fast the disease spread, taking in account your immunity, taking in account the population size of the city, taking in account how much medicine is provided by CDC, and so on. All this is nesting inside of the problem. So you do chain rule in all of this. If you plan to build cities, to build devices, to send shuttles into the space, to do coding, you need to know that, and right now you're learning it to be good at it. So motivate yourself with those good examples. Sine is the 17. 17 sine of x squared. And this is what you're going to have on the mastery exam. We will give you a couple functions with double chain rule. That's chain rule twice. How do I know? Because the inner function is x squared. Then the outside function is sine. And then one more outside function is 17 sine. How do I know? Plug in something, plug 0. First you square it, so that's inside piece. Then you do sine of the result, that's the outside piece. And then you do 17 sine of the result. So the last step is the last sine. That's chain rule twice. So this is the inner level, and then this piece is inner level. Chain rule tells you exactly the same rule, how to work with functions like this. It's exactly the same way. Let's write it down right below over here. The chain rule says, like a Russian doll, it might be many dolls there, not only two. It says, I cannot touch the red part and the purple part. Because to touch it, I need to open the Russian doll first. The outside piece is 17 sine, so you can differentiate that. What is derivative of 17 sine? 17 cosine, not too bad. Now, the trick is copy everything you see. Sine of x squared. Make sense? Copy it. Because that's what I keep telling you. Copy everything you see. You cannot touch it yet. Then chain rule says times the derivative of the function inside. But there are two functions inside. So you have to go in order because it's the second layer now. You cannot touch x squared yet. But you can touch the inner sine, right? Differentiate that one. Derivative of sine is cosine of what? X squared. Do not differentiate that. Copy. One more chain rule. Now, finally, I digged enough to reach x squared. And I'm differentiating x squared, and it gives me 2x inner. So this is how chain rule looks like. In most of the real-life applications, it will be something like this. It will have 2-3 layers. Outside layer gave me 17 cosine, inner layer or middle layer cosine, and the last layer 2x. How do you know where to stop? Many students ask me this question. The last piece actually is just x. The last piece inside is just x. If you differentiate x, it gives you 1, so you know where to stop. The moment it gives you 1, you're done. Or you just know that the moment you reach this inner piece, you differentiated it, you stop. Make sense? Now, how about quotient rule? So combinations. Combinations are the one which are pretty awesome, and so we're gonna ask you to do this more and more. For example, so let's do it before I do 4. Product rule, quotient rule, and chain rule at the same time with different combinations. You just need to be careful. That's kind of the whole idea here. Just be careful. F of x is 4x squared minus 9 raised to the 6. Negative 9x squared minus 4 raised to the 14. Yes, so this is what you're going to have in the mastery exam and exam 2 and final exam. Like these kind of functions. We give you product of several functions, quotient has several functions, and all of them or some of them have chain rule. Because this is basically what you're actually going to have at your job. Like this is what they're going to be checking. This is what they assume you're really good at. You're really good at. Calculator and computer can do it for you, but it does mistakes. So we need to make sure you can fix the mistake, catch the mistake, and change it. So, first of all, I see product. Do you guys see product? Here it is. So I know it's going to be U times V. At this point, you're supposed to be good at it. We already had first exam. You have no chances but just to be good at it. U times V, U prime V plus V prime, right? I can even say it fast, which is good. But then I see each function has a chain rule in it. Because the first function is 4x squared minus 9 raised to the 6. That means this is a polynomial. This is the polynomial 6th power, which having polynomial inside of it. That's the idea. Now, the second one has the same problem. Now let's do it slowly, step by step. Using colors, I think will make it better. U times V says differentiate the first function. Or the second one, you choose the order. I like starting differentiating right away. So I want to do U prime V plus UV prime. That's my notation. You don't have to have the same notation. What is U prime? Who knows now? 6 goes down. Yes. Do you all see what's the outside piece? So this is how I see it in my mind. This is how I teach when I tutor people one-to-one. This is how you should see it. It's U to the 6, or right? Or something to the 6. Something to the 6. I know how to differentiate something to the 6. 6 goes down. Copy this something. Change the power. Make sense? So like if you keep saying it, it's actually not too bad. So something to the 6. But don't forget to copy. And now you're not done yet. How do I know I'm not done yet? If you have so many product and quotient rule, everything should be touched at some point. If you never touched 4x squared minus 9, probably you missed a piece. Make sense? Because when you're differentiating everything, and it's all nested, each piece should be differentiated at some point. So if you never had 8x anywhere, the derivative of 4x squared minus 9, that means you missed some piece. You lost it. So I do times, different color, 8x. That's derivative of the function inside. So this was just derivative of U function. Derivative of the function inside, outside. 6 goes down, everything to the 5, times derivative of the function inside, which is 8x. Not too bad. You see, if I don't write, this is inner function, outside function, inner prime, outside prime, it's faster this way. Now, the product rule says copy the second piece. So it's going to be negative 9x squared minus 4 to the 14. Just copy because that's what product rule says. Not too bad. And now you change the order. Remember? It says now copy the first piece, which is 4x squared minus 9 to the 6. So copy the first piece, which is U. And now differentiate V. So we'll have this for V. But V has chain rule in it as well. Outside function is something to the 14. Something to the 14. Yes? 14. What's the most important piece not to make mistake? Copy. Yes, good job. Copy the inside piece. Then one more thing people keep losing. 13. I see this in the exams a lot. You got excited, you did not forget to copy the piece, and then you forget to change the power. So 14 goes down, something, copy that. Then change the power, 13 times. Now you can look inside and differentiate the function inside. Derivative of the function inside, which is negative 9x squared minus 4 is, good job, negative 18x. Look at this. This is the answer. And this is going to be your one of the longest homework in this Calculus 1 class. Chain rule is one of the longest homework. We have to give you like 50 problems with all of this in it, and you just do it. That's why this homework is not due this week. It's either due Wednesday or next Sunday, I will decide. But this is the one you have to go through. If you reach 90% of the homework, you're ready for the second exam to do it. So generally, you have to do it many times. Questions, ask me. This was a long problem. Do you have questions?
I'm not quite keeping track of the first formula. So U prime and V.
Mm-hmm.
That looks like
Let me
U
sign.
prime and U.
U prime is this piece.
Gotcha.
Times V right, is this piece times v, copy. Then copy u, then v prime.
Threw me off because
No, definitely ask. And you can do your own order since it's all added up together and multiplied. You can switch the order. But just don't forget, one should be differentiated, the other one should be copied, and then you switch. The other one should be differentiated, the other one should be copied. Every time you differentiate, it might be chain rule, quotient rule, and product rule there.
I like to define each one and crisscross.
Yeah, I know what you're talking about. The table. I saw people doing it. Yeah, good job. That's good too. Definitely. All depends on how your brain likes. It's like if your brain enjoys doing it, then do it. Now, let's do something with a quotient, of course, because you guys love quotient rule. So, and this is the one actually people stuck in the homework, I know. 2t plus 3 all over 6 minus t squared cubed. And then all of this prime. Interesting. I do see quotient rule here, and I see cubed outside. So what usually people stuck with is where to start. How is it even gonna work out? Same idea. Try to find out what is the last step you're going to do in this mess. Yeah.
Sorry, just the last question though. Sounds like your final answer.
Yeah, the box. All this box. There should be, so piece times a piece plus piece times a piece. Yeah. Derivative, not derivative, plus, not derivative, derivative. Yeah, you guys should stop me if I'm too fast. Here, plug something in and you will see what's the last thing you do. So if I plug 1 or whatever, 0, doesn't matter. The first thing I will do, I don't know, 2 times 0 plus 3. Then I will do 6 minus 0 squared. Then I will divide those two results. So I have quotient almost at the end. But there's one more thing to do. Raise everything to the third power, right? So the last thing to do here is cube function, which means there's a fraction which raised to the third power. So fraction is the inner piece of the polynomial of third power. Make sense? And that's how you check yourself. Plug something in and ask, what am I going to do last? So if I see here something inner, something to the third power, I know how to differentiate that. 3 goes down. Something squared. Make sense? So like this is how good you should start. And now what people just really freak out, what's inside? What's gonna go inside? Copy, exactly. And even though it's a huge fraction over here, maybe it will have arcsine plus secant minus and over something, doesn't matter. Copy means copy. It means you cannot touch it because it's still inside of the Russian doll. Until you finish differentiation, you cannot differentiate that piece. So the outside piece here, that's a derivative of the cubic function. 3 goes down, piece inside to the square. Make sense? Times, now chain rule starts. Chain rule says, now I allow you to look inside. And you're like, okay, oh, there's a quotient inside. Now you have rights to look inside. And now you need to differentiate that piece inside. Okay, that seems to be like a long process because it's a quotient rule. You cannot go around that. So let's start doing quotient rule. The quotient rule says I always recommend to start with the squaring the denominator because then you don't forget to do it. 6 minus t squared, squaring the denominator. Then quotient rule says u prime v minus uv prime. Remember? U over v prime is square the denominator and don't touch it. Don't simplify. Don't use this square of the sum or difference. Just leave it. And then u prime v minus uv prime. Order matters here because of the negative sign. I recommend to start with differentiating the top, but you don't have to. Derivative of 2t plus 3 is 2t plus 3 gives you what? 2. Do you understand that? 3 gives you 0. 2t, what's the speed of 2t? 2. So when you differentiate, 2t becomes 2. Copy the denominator, 6 minus t squared, minus, copy the numerator, which is 2t plus 3, Differentiate the denominator, which is 6 minus t squared, becomes negative 2t. Done. This is the answer. So this piece on the right is the answer. 3 goes down, copy the fraction to the square, times, differentiate the fraction, because the fraction was the inner part. But to differentiate the fraction, you use quotient rule. Quotient rule here performed. Do we need to simplify this? Unless we tell you don't. But I think in your homework you have to. I will check. It really depends from year to year. To simplify, they will ask you to do square here and square here separately. 6 minus t squared and 6 minus t squared becomes 6 minus t to the 4, and so on. So basically collected the terms. Sometimes something simplifies and it looks better. But this is good enough to me. How do you like it? Not too bad. Now, the last part to show you is what is happening. Okay, of course we can do product rule and quotient rule and chain rule at the same time. There's no limits of how crazy all this can get. There's no limits on that, trust me. It just gets crazier and crazier. What I wanted to show you is the higher order derivatives. These are in your homework as well. At some point, it's not that bad. Higher order derivatives, we just want you to understand that. I did mention it before. If you have distance, and you differentiate distance, that's s, remember? It becomes speed or velocity. Speed and velocity is not the same thing. At some point in physics, they will explain you that one has direction and the other one doesn't. So I'm driving 5 miles per hour, and that is speed. But if I'm saying 5 miles per hour positive or negative, then I think that's velocity, and so on. Distance and displacement have the same thing. From here to here, this is 35 centimeters. But if I'm saying it's to positive direction, then it's displacement, yes. Then if you differentiate v, I would do like this. Differentiating distance becomes velocity or speed. Differentiating this becomes acceleration. Acceleration. And then if you check Wikipedia, actually let's keep going. After that, no, there's a jerk, which is funny. I'm not making this up. I was surprised too. So it's A, and then there's a J. So very interesting. Usually it's S of t, V of t, A of t. And there's one more thing there. I forgot. You can check Wikipedia and so on. It's pretty interesting how they're making all those names. That's physics majors. You guys should know that. But basically, jerk means changing super fast. It's like how fast acceleration is. You know, like what is instantaneous acceleration? It's like jumping, something like literally jump. You know, that's the idea. So my question is, can you find A of t if S of t is cosine of 7x. Let's do square. Actually, let's not do square. Yeah, let's do square. It's fine. So what's the big deal? Let's just differentiate twice, right? Now you know that. The first derivative gives you velocity, second derivative gives you acceleration. Find acceleration if distance is provided. Okay, S prime of t is derivative of the cosine. You see, I see cosine right away. Derivative of the cosine is negative sine, good job. 7x squared. Done or not? Yes, and this is where you will get credits. You know, if you don't forget that there's something going on inside. There's a function hiding inside. And I never mentioned that. And we're not going to tell you, use chain rule to differentiate. No, you have to decide by yourself. There's a function inside. So now I'm like, oh, if there's a function inside, I do times, and that's chain rule. Chain rule tells me to do that. Don't stop, basically. Chain rule says don't stop. There's something going on inside. 14x, a speed of the function inside. It's 14x. And now, what this is velocity, v of t. And now to find acceleration, what do you have to do? Differentiate again. And that's going to be a product rule with chain rule. Do you see that? Then I'm differentiating minus sine 7x squared times 14x prime to get acceleration. That's u times v. u v. u times v with chain rule again. Let's do it. Derivative of u is, and you see the function looks almost the same, but it switched to sine. Now it's going to switch to cosine again. Derivative of negative sine is negative cosine, right? Sine doesn't change anymore. Copy the inside piece, 7x squared. Then chain rule says, now look inside, times 14x, and this was only u prime. U prime. Negative sign should be inside, like this. Do you all agree? So you're kind of repeating the same process, but now you just add more pieces in this puzzle. Then it says copy v. Okay, 14x. That's my v. Plus copy u, negative sine of 7x squared. That's copying u. U prime v times u v prime, and now we just need to differentiate v. V is 14x. What is derivative of 14x? 14. So this is the idea of product rule and chain rule at the same time. Why did we do it? Because for the given distance, we wanted to find acceleration. If you differentiate one more time, you will get jerk, and one more time you get something else, like a jump or whatever. Let me know if you have questions about this, but this is going to be our goal, to practice a lot. Chain rule, product rule, quotient, chain rule, exponential function, cosine, sine, logarithm. See you on Monday. Let me know if you have questions, post questions in the forum. Have a good weekend.